Section 02 in the text deals with solving inequalities. And in order to work with inequalities and especially to express our solution in terms of an interval and maybe sketch that solution set, we need to be very familiar with the appropriate notation. So in terms of sit notation, if we have all x values, and this colon here means such that, so all x values such that a is less than x is less than b. This is equivalent to having the open interval from a to b. And if you wanted to sketch that solution set, you'd say, on a real number line, all numbers which are bigger than a, so if you're not equal to a, you have an open circle there, up to but not equal to b, and then you would shade in between. Likewise, if you have all x such that a is less than or equal to x, less than or equal to b. That is the closed interval from a to the closed interval at b. So in terms of sketching this solution, it's very similar to what we have above, except now we are including the points a and b. So the circles that you draw there are closed, and then we shade everything in between. Now, in addition to having a fully open interval or a fully closed interval, it is possible to have half open, half closed. If we said all x such that a is less than or equal to x but less than b, that is an interval which is closed at a up to being open at b. So if we were to sketch this solution set, we're going from a to b. The number b is not included. The number a is included. And then we shade everything in between. And we can also do this going off to one direction. And by that what I mean, if we had all x such that x would be less than b, x is anything less than b. So we would have the open interval from minus infinity to b. And a very important observation is whenever you're using plus or minus infinity in an interval, we always make that open, because we don't think of infinity as being a number, but really being an idea, absolute largest negative number that you can possibly approach. In terms of sketching this, everything less than but not including b. Likewise, if we have all x values such that a is less than or equal to x, so that would be closed at a going to infinity. So in this case, the a would be included, so closed circle, and everything to the right. And then lastly, we use this notation, a kind of fancy script looking R. This stands for the real numbers. And as an interval, we think of the real numbers as being all possible numbers, minus infinity to infinity. So as a number line, everything would be shaded in. So let's move on to thinking about how we would now solve inequalities. When it comes to solving inequalities, we use the same exact approach that we would use for solving general equations. The idea is that what we're going to do is just transform the inequality one simple step at a time until we see what the solution set is. And for example, when I mean one simple step at a time, what we typically do is add or subtract a quantity to both sides, or multiply or divide both sides. So if you have a less than b to start with, then if you add the same quantity c to both sides, you preserve that inequality. If you have a c quantity which is positive and you multiply both sides by it, you preserve the inequality. And where we have to be very, very careful, this is usually where common mistakes are made, is if you multiply by a negative quantity, you need to change the order of your inequality. And we will see that in an example in a few minutes. So let's look at a few examples. So let's solve the inequality express its solution in interval notation, and also graphically, graph out that solution set. So we have 5x minus 3 larger than or equal to 6x minus 4. The idea here is to, just like if we were trying to solve a linear equality, is to get all of the variables on one side, all of the numbers on the other. So in this case, what we could think about doing is, subtracting 5x from both sides and adding 4 to both sides. When we do that, on the left, 5x minus 5x, the 5x we have there cancels. Minus 3 plus 4 is a 1. And on the right-hand side, we've added 4, so minus 4 plus 4 goes away. 6x minus 5x is 1x. So what we end up with is 1 bigger than or equal to x. So expressing this in interval notation, we're thinking in words, x is everything less than or equal to 1. So this would become minus infinity up to and including 1. So this would be our solution expressed in interval notation. In terms of a graphical approach, we want to include 1, so a closed circle, and everything to the left should be shaded in. So let's do the same thing here with 7 less than 5 minus 2x less than or equal to 9. So maybe the first observation to make is that we can have more than one equality involved in one of these equations. And having two equalities involved is a very common thing. So the ideal situation here would be to leave that x in the middle of the two inequalities and then see what we can figure out about it. So to isolate that x in the middle, what we're going to have to do is subtract 5 from each part. So we'll have 7 minus 5 is less than minus 2x is less than or equal to 9 minus 5. So that leaves us with 2 less than the quantity minus 2x less than or equal to the quantity 4. Now the last step in terms of isolating this x in the middle would be to take care of this minus 2. So what we would like to do is multiply everything by minus 1/2, i.e. divide by minus 2. So we would have 1 over minus 2 times 2, and x in the middle, and 1 over minus 2 times 4 on the right. But recall, since we are multiplying by a negative quantity, we need to change the order of our inequalities. So that's a very important observation. So on the left, 2 divided by minus 2 is minus 1. And on the right, 4 divided by minus 2 is minus 2. So if we express this in terms of in terms of an interval, this becomes what? X is bigger than or equal to minus 2, but less than minus 1. And sketching this on a number line, we go from minus 2 to minus 1. We're including minus 2, but we are not including minus 1.